Hey, POA students, this is your section 3.8 homework. So let's go ahead and just jump right into it. We evaluated a lot of expressions today, then we took a little quiz. Hopefully that wasn't too traumatic for you. So when you're evaluating expressions, we give you this information up here. We say x is -2 and y is equal to 4. And so you're supposed to use that information to tackle this expression and then several more. And there may be a couple or a couple of ideas here that you may be unfamiliar with, but we'll help you out. So let's start with 2x plus y. I'm going to zoom right to there. And so I'm going to just start rewriting this expression as 2, and then when I get to where I see an x, I'm going to put parentheses, and instead of writing the x value, I'm going to write -2, because I know x is -2 now. And so then I'll keep writing plus, and then I put parentheses where I'm going to plug in for y, and I put the value for y there instead. Okay, so I have 2 times -2 plus 4, then I just use my order of operations. -2 plus 4 is +2 times 2 equals 4. First one's down. All right, and I'm going to just draw a little line here to keep my work kind of organized. Let's do this one right here so we don't run out of space. So that's 2x plus y. I'm going to rewrite it, and when I get to the x, I'm going to put parentheses, and then I'm going to fill in -2. And then I have plus, and I have a y, so I'm going to put parentheses, and I'm going to fill in for that y with 4. And so I use my word of operations again, multiplication first. 2 times -2 gives me -4, plus 4, and that gives me 0. So the second one comes out as 0. All right, so this next one, you may not be familiar with this symbol, but that's okay. I'm going to help you out. This says the absolute value of x plus y. We talked about it really early in the school year, what an absolute value was. It's the distance from 0, a number is. And so again, I'm just going to start rewriting. I'll make the line, because that's the start of the absolute value sign. I'll put parentheses -2 plus parentheses 4, because I filled in for x and y with the same things I've been doing so far. And then I do -2 plus 4, I get 2, and then the absolute value of 2 asks the question, how far from 0 is 2? And of course that is 2. So the absolute value of 2 is 2. All right, let's finish up here. We'll do another absolute value problem. And so I'm going to write my parentheses where I'm going to put in my x, and I'll color code it again, -2 minus parentheses, and I'll plug in my y, which I know is 4 in this problem, and then I end my absolute value. So I do -2 minus 4 is -6, and so now I need to do the absolute value of -6. The absolute value of -6 asks how far from 0 is -6. Well, it's 6 steps, so it is 6. All right. For each table, plot the ordered pairs on the coordinate plane provided. Note in this table the x and y coordinates are all non-negative, so the grid contains only quadrant 1, which we usually write like that. Whoops, 6. Let's go ahead and start plotting. I have 0, 0. I start at the origin, and that's that point. 1, 2 means I go from 0 to 1 on the x-axis, and then up 1, 2, and then I make my point. Now 1, 5, I go over 1, then up 1, 2, 3, 4, 5. And I've gotten those two done. Now I do 3, 3, so I go over 1, 2, 3, and then up 1, 2, 3. So there's my point. 4, 1, I go over 1, 2, 3, 4 to the right because it's +4, and then up 1. 5, 6, I go over 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5, 6. Now I go 6, 3, that's over 1, 2, 3, 4, 5, 6, up 1, 2, 3. 6, 7, over 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7. Over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 0 leaves a point right there, and I should be all done. Cool. Let's keep going. In this table, there's a mixture of positive and negative XY coordinates, so the grid contains all 4 quadrants. Remember, this is 1, 2, 3, and 4. All right. Let's start plotting some points. So negative 4, comma 6. So negative 4, I start at the origin. I'm going to go back 1, 2, 3, 4, and I'm going to go up 1, 2, 3, 4, 5, 6. I went left because the x value was negative, and I went up because the y value was positive. All right, so negative 3, comma 5. I'll get rid of my origin dot here. Negative 3, comma 5. I'm going to start at negative 3, go over 1, 2, 3, and then up 1, 2, 3, 4, 5. So I went left because the x value is negative, and up because the y value is positive. All right, negative 2, 4. That's another left, then up. That's negative 2, 1, 2 to the left, and then up 1, 2, 3, 4. Okay, looks like it's going pretty well. Negative 1, comma 3. That's left 1, up 3, over 1, 1, 2, 3. I'm noticing a pattern, but I have no idea if that pattern holds here. So 0, comma 2, that means I go left and right 0, then I go up 2. So that was an easy one. 1, comma 1, I go to the right 1, up 1, because the x is positive and the y is positive. I go right 1, up 1. All right, 2, 0, so I'm going to go to the right 2 because that's a positive x, and then up and down 0 because it's a 0 value for y. All right, now 3, comma negative 1, that's to the right 3, down 1, 1, 2, 3, down 1. And 4, comma negative 2, that's to the right 1, 2, 3, 4, and then down 1, 2. We go down because it's a negative y value. We got this nice linear pattern that showed up. All right, last one. So we have negative 8, comma 1, and so I see left 8. I'm going to zoom in a little bit more. Left 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 1. So I went left 8 because it's a negative x value, up 1 because it's positive y, negative 6, 0. I'm going to go to the left 1, 2, 3, 4, 5, 6, and up and down 0. Negative 5, negative 0.5, so I'm going to go left 1, 2, 3, 4, 5, and I'm going to go down 0.5, which is about a half. So there we go right there. Negative 2, comma 2, so that's left 2, 1, 2, then down 2, 1, 2. I'm seeing a pattern emerge again. It looks like they're all lining up. That means they are collinear. 0, comma negative 3, I start at the origin. I don't move left or right because the x value is 0. And then I take 3 steps downward, 1, 2, 3, because the y value is negative. 2.5, negative 4.5. So I'm going to go to the right 1, 2 and a half, and then go down 1, 2, 3, 4 and a half. Because the x value was positive, whoops, and the y value was negative. There we go. 5, comma negative 5, so I go to the right 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5 and a half. And 7, comma negative 6.5, 1, 1, 2, 3, 4, 5, 6, 7, and then down 6 and a half, 1, 2, 3, 4, 5, 6 and a half. So there we go. And then we're down to the last one here, 10, comma negative 8. I go over to 10. I'm just going to go all the way over because it's all the way over here at 10, and then down 8. 1, 2, 3, 4, 5, 6, 7, 8. And there's my last point. Awesome. Let's keep going. Back to these square box problems. So I need to think of two numbers that multiply to make 15 and that add up to make 8. And so 15, I can think of numbers that multiply to 1 and 15, multiply to make 15, but they add up to 16, so that's not it. How about 5 times 3, that's 15, and they do add up to 8, so I think it's 5 and 3, because 5 plus 3 is also 8. And so I just made my list of numbers that multiply to make 15, I just went from there. What is the rule for this input-output table? Okay, so we need to figure out how to go from the inputs to the outputs. I'm going to start, I already see a 0 column, so that tells me that there has to be a plus 3. I'm going to kind of put a process column in here. That means everything has to have a plus 3 in it because the 0 row has a plus 3 in it. And so now I'm going to go to the positives because I like positives. So I need to think what plus 3 gives me 7. So I need something plus 3 gives me 7. And I know that that number is 4. And so I'm going to do a little thought bubble out here. I need to use multiplication or squaring to go from 1 to 4. Because I need to use my input of 1 to get this 4 so that I can then add 3 to it and get 7. So the thing I'm going to think of is I'm going to try 1 times 4. And so I'm going to write 1 times 4 here, and that's what I think the rule is probably going to be. So then I'm going to test that out. 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. That worked. 0 times 4 plus 3 is 3. Negative 1 times 4 is negative 4 plus 3 is negative 1. Looks like Mr. Boswick's on to something here. Negative 2 times 4 is negative 8, plus 3 is negative 5. And so my rule has to be take the input times 4 plus 3, and you get the output. Now you can also find that times 4 bit. Some of you are noticing this pattern because this table has a plus 4 pattern in the output column when the input column has a plus 1 pattern. And if you don't get that yet, that's okay, you will, but that's just a nice thing to notice. That's another strategy for that kind of problem. Find the next 3 terms in this sequence. So we need to figure out what the sequence is doing first. So I see 3 plus 8 gives me 11. I'm just guessing here. 11 plus 8 gives me 19. 19 plus 8 gives me 27. 27 plus 8 is 35. So I need to do 35 plus 8, and I'll get, that is 43. So 43 plus 8 gives me 51. And then 51 plus 8 gives me 59. So there they are. There's my next 3 terms because it adds 8 each time. Cool. All right, describe the relationship represented by this graph by writing a complete sentence. Hours at service fair, I'm noticing, and number of volunteers, so volunteer recruitment. So it looks like if we're recruiting, that means we're trying to get more volunteers, and we're at a service fair. If you're not sure what a service fair is a place where a bunch of nonprofits might advertise themselves to people who are looking to volunteer. And so for this particular organization, the longer they spend at the service fair, the number of volunteers increases. And so that's what I'm going to write. And I'll zoom in quite a bit so I can actually fit this in. The longer they spend at the fair, the more volunteers they recruit. So the longer they spend at the fair, the more volunteers they recruit. And so if you haven't noticed this pattern yet, usually when you're describing a graph, you say what happens to the dependent variable when the independent variable changes. So as I increase the number of hours, I have to notice what happens to the number of volunteers. And in this case, it increases. All right, so this is another one of those problems where it's in your best interest to try these all first, and then I'll just write down all the answers so that you can check your work. So I would really recommend pausing right now and then coming back to it in just a sec after you've tried it. So -8 minus -7 is -8 plus 7 because minus and negative is adding, and that's -1. 0 divided by -6 is 0 because anything divided into 0 gives you 0. 6 divided by -1 is -6 because a positive divided by a negative is a negative. 6 divided by 1 is 6. Negative times a negative is a positive. 11 times 5 is 55. 2 minus 14 is, I'm going to step past 0, and then I have to take 12 more steps. So it'd be -12. -10 plus 4, I get closer to 0, so that's going to be -6. -5 times 8, that's negative times a positive, which gives me a negative. 5 times 8 is 40. -7 plus -5 is -12, because that's just like -7 minus 5. We get a little farther away from 0. -6 divided by -6, negative divided by a negative is a positive. 6 divided by 6 is 1. 55 plus a -25 is just like 55 minus 25, and that is 30. Let's see what conclusions they want us to draw this time. Consider what you know about the multiplication of signed numbers, then complete the following statements and answer the following question. The product of a negative number and a positive number is negative. The product of two negative numbers is positive. What is the relationship between the product of -a times b and the product of -a times -b? Well, look. They are opposites. One's positive and one's negative. All right, there's your homework for you. Hope you had a good time. Nothing too crazy happened.